Hello, everyone. Thank you for joining us today for our ALS Webinar Wednesday series. My name is Alejandra Herrera, and I'm the Marketing Coordinator for ALS North America. I will be facilitating the webinar today. If you're having technical issues with your webinar platform or you have any questions, please use the chat function at the bottom of the screen. You can also select the hand icon to notify me of your status so I can assist you. All questions regarding the webinar material will be answered at the end of the presentation. Our presenter today is Darlene Stosny. Darlene has been working in the environmental industry for over 30 years and 16 years with ALS. Her laboratory experience spans waters, soils, and in the last 7 years has come to include tissue and air. Darlene is now the ALS Canada Technical Specialist for Air Quality Testing. Today, Darlene will be discussing canisters and TD tubes behind the scenes. Darlene, I will now turn it over to you.
Thanks very much, Alejandra, and thank you to everyone who has taken the time to take in this webinar. I'm going to do a brief overview of what we'll discuss in the webinar today. And by all means, when we get to the end, if there's any questions, please feel free. There's also contact information at the end if you want to contact me directly or call me by phone. So when we talk about insights regarding our canisters and tubes, TD tubes, these are things that I would say probably the vast majority of people are aware that happens, but maybe aren't aware of the timelines and details and why we ask for things that we do, or why we insist on additional time or try to explain different terminology. So we'll run through some of those things. Also do those related to canisters as well as thermal desorption tubes, but I do want to let you know that primarily this will be about canisters, and then I will discuss the thermal desorption tubes on the side, but they are probably a little bit more minor to the presentation. So we'll talk about the differences of whole air versus taking pump and tube samples, what we do when we actually prepare receive canisters, and the dilutions that are performed, what leak testing canister means for us, and the frequency, PSI versus inches of mercury. So when anybody that works with any type of pressurized equipment will be familiar with pounds per square inch, or PSI, and inches of mercury. And in this industry, we tend to use both. The calibration of our flow controllers, the TWA flow controllers, are the long-term ones. So they are longer than an hour. So 4, 8, 12, 24. They're the ones that have a diaphragm in them, versus the short-term grab samplers, and their limiter for flow control is a critical orifice. And then preparing and receiving TD tubes. So our thermal desorption tubes are of two different kinds. There's a multimedia, which we use for the active sampling, so that would be with a pump, and then our passive tubes, which just have a single media in them. And when we talk about active sampling for TD tubes, one of the things that is often concern for us as a lab is safe sampling volumes. So while each tube can hold a significant volume of air, so when you're sampling with a pump, you're sampling volume, so you're sampling flow rate over time, and you're collecting a volume onto that tube. Not all compounds, if there's a high concentration of that compound, will stick onto that sorbent media if you overwhelm or if you saturate the tube. Then our canisters, as you see here, we have two different options as far as flow controllers are concerned. And the one in the center shows our 1.4 liter canister. And as I had mentioned before, the flow rate is determined by that small flow restrictor that black arrow is pointing to. And we generally call these grab samplers. And what we do when we prepare these is we essentially we assemble them. So this gooseneck part is independent from the portion that actually attaches onto the canister and the pressure gauge. And we we thermally clean them in pieces. And the reason for that is A, you get a more thorough cleaning, and B, when as a client you want to order a flow controller, we can then put in that critical orifice based on the time that you've asked for, which for a 1.4 liter can is your 4, 10, 20 minutes, 40 minutes, or sorry, 4, 10, 20 minutes or an hour. The difference in setup, so in this particular flow controller, we pull the whole thing apart. In this particular flow controller, again, we do take it apart, but the controlling object here is this cylindrical portion, which is a diaphragm. And when we calibrate these, we calibrate them using a digital calibrator, and there's a diaphragm in here so that there's a screw here that we can actually tighten or loosen, and the diaphragm inside is then adjusted to actually set the actual sampling time. And our digital calibrator goes to 2 decimal places. And why I'm saying that is that's relevant when you actually take your beginning and final vacuum pressures on your canisters. You're taking it just to the whole number. And you're using an analog vacuum gauge that we supply as an independent in every order, but you also have that independent vacuum gauge right attached to your flow controller. When we measure, or when we calibrate the flow controller, we're using a digital calibrator that goes to 0.01. So it actually is pretty specific. Now, I know that there's always a concern with our clients when they look at the starting vacuum on their form when they receive it with their canisters versus the ending vacuum, and then the number that we then attribute when we get the canisters in-house and we put on the report. Please note that when you're doing whole air sampling, the best analogy I can think of is, excuse me, it's important to get the canister full to at least between -5 and -8. But the best analogy I can think of is if you're taking a water sample, unpreserved water, and you're putting that into a Gen Chem jar. We always let our clients know that you need to fill it at least to the neck. So whether you fill it to just below the neck or just above, it would be rare that we would say we don't have enough sample, because we're just taking an aliquot out of there. Now, if you only fill that water container half, we may call you and say, look, we're going to have to do a dilution because we don't have enough volume of sample. So air is exactly the same. If we don't get that canister filled enough, then we may have to do a dilution because there's not enough sample in there. So that's sort of the best analogy. When you're doing whole air, it is not as critical that the exact volume of the ending volume be known. Whereas when you're doing tube sampling with air, of course, that beginning and ending volume, that determines your concentration based on that and the time sampled. So it's really important to know that there is a distinct difference. It does make whole air sampling in some ways easier, but it does always cause a concern, especially with field staff, when they see those numbers slightly vary. Keep in mind too that your air, when it heats up, it expands, so that final vacuum pressure may be a little lower. And if it's very cold out, and we've had clients sample in -27 degrees out in Manitoba, then when we get the canister in and warm it up, while it might be significantly lower when you're out in the field, it might be quite a bit higher when we get it up to room temperature. And that is our goal. We always bring to room temperature. Conversely, if it's really hot out and we then bring it into the lab to room temperature, it may be a little bit less. We will definitely always call you or notify you if there's a concern that the canister is not full enough. And what that means is if the canister does not get filled to between -5 and -8 inches of mercury, then, so say you're at -10. -10 is probably the cutoff, but there is a chance at -10 we would have to do a slight dilution. And I'll touch on that a little bit further on when we talk a little bit about dilutions in the next slide. but I really wanted to talk a little bit about filling them properly and the dilutions that we do for this. So I'll go to that when we get to the next slide. So when you're looking at canisters, and we often talk about why is one better than the other. So what we do with the canisters is we get a stable sample. But keep in mind that the reporting limits that we're giving you on your report, so if we don't have to do a dilution on your sample, so there's no comment as far as increased reporting limits, we have actually diluted the sample with nitrogen if it's for VOCs and sulfurs, with helium if it's for fixed gases. And why do we do that? Well, when we get the canister and it's under slight vacuum, we have to get that air out of there. And so we have to pressurize that canister. Now we leak check the canister at every single stage. So we're leak checking when it comes in, we take the final vacuum, we leak check it. Then we're going to add the diluent, so the dilution gas into it. And depending on the analysis, it's either going to be nitrogen or helium. Now I can hear some of you saying, you know what, I want what if I want fixed gases and sulfurs and VOCs? For the ones of you that have done sampling with us, you'll note that we usually ask for a second canister if you're doing fixed gases and sulfurs. And I will touch on that just a little bit later as to why that's important. So let's go back to the dilutions. The dilution generally is 1 and 2, but it's not something that you will see on your report because we already account for that. We have to put that diluent, I'm sorry, into the canister in order to get the air out. What will happen sometimes is when the canister isn't filled enough, we will have to add additional nitrogen or additional helium. And here's where dilutions that will affect your results come into play. So let's say, for example, we get a canister back we send it to you between -28 and -30 inches of mercury. For whatever reason, let's say there's been negative pressure, so it was hard to get any sample into the canister. We get the canister back at -22. Is all lost? No. So what we do when we get it in, again, we do the leak check on the canister. We will then add as much nitrogen as we need to, and we keep this to a minimum because we want to keep the dilutions down as it requires to be able to run that sample. So I can give you, and I'm happy to provide this for any of you that are interested in this calculation going forward. But so when a sample comes to us at -22 inches of mercury, that works out to about 3.9 psi. When we put this all through allows us to be able to hit the hold times for the sulfur, which is really important. Sulfur, we've gone through the canister studies, and if you're interested in this, we can provide that we do have a stability for up to 7 days for sulfur compounds in canister. I know that when you're looking at MECP, C of A's, or certificates of approval, or ESAs, depending on the terminology, there is always a note that they need to be sampled or analyzed within 24 hours. And that was traditionally based on using Tedlar bags. So just a background on that traditionally sulfur was sampled into a Tedlar. It has a shorter hold time. The canister does afford you some additional stability and a little longer hold time. So again, the reasons for those two particular canisters needed when you're doing sulfurs and fixed gases is because of the different diluent gases that we're using. If you don't need nitrogen as a report when you're doing fixed gases, let us know, because then you can go down to one canister. There's certainly a cost savings because we do charge for the rental of the two canisters, but we want to be able to give you the best possible data. The carrier gases on our equipment, just so that you know, is helium. So one of the reasons that we cannot provide helium is that we use it as a carrier gas on our instrumentation, and so it doesn't work really well because it tends to be ubiquitous. However, we've actually been able to set up an instrument separately in a separate room, and we will be offering helium and hydrogen analysis soon out of the Waterloo location. Currently, we can provide that. It's out of Edmonton. So as a client, you just drop the canisters off and we take care of where it has to go, but it will be more local. So that will be easier for you. All of our instruments are set up. I'd mentioned before about PSI versus inches of mercury. Oddly enough, while our canisters are set up to look at inches of mercury, all of the instrumentation in the lab looks at PSI. So if perhaps you end up getting an email from one of the techs because it's been forwarded from one of our account managers, please feel free to message me back or message our lab manager back, Andrea Armstrong, and we can do the conversion calculation to let you know where we're at as far as inches of mercury, because I know on your documentation that would likely make more sense. But never be worried that there's some sort of a problem as far as the conversion. We can do that for you. We're happy to provide that. I'm also happy to provide the calculation if you'd like to keep it in hand. So one of the things that we look at when we're getting canisters ready, when we get your order, is the timeline. I know that our clients often hear, well, we need a week, 3 to 5 business days at least. And that sometimes presents a concern because you get a client calling you up and saying, I want you to come sample in the next 2 days. So the timelines are not there because we don't have the stock on the shelves. The timelines are there because we have a standard operating procedure to prepare these orders and prepare the canisters. And as I had mentioned, every single step of the way, we're doing a leak check on that canister. So that means even if the canister is sitting on a shelf as stock, before we can ship it out, it still has to go through that leak check process. The flow controllers that you require, they have to be, we put those together as they are needed. Do we have some built? Yes. But if there's a large volume needed, then sometimes we have to borrow from another order to be able to put out the flow controllers that you need, or the grab samplers, the short-term samplers that you're looking for. So the more time that you can give us, the better. And the other reason that we ask for those timelines, and I will show you in a subsequent screen, is the shipping time. So generally we ship these canisters by ground. If it's in Ontario, we take advantage of our courier staffed network in order to be able to drive within the Toronto area, within the Ottawa area, London. So within our network area of labs, and within a geographical area of those particular labs, or a close geographical area, we do some deliveries. But anything that has to go out of province or has to go further, keep in mind that we're shipping it by ground, and that's at no cost to you. What we do charge for is if it has to be an expedited order. So while we need 3 to 5 days to get these canisters ready, if it takes an extra day or two to get shipped to you, then that eats up into the time that we can prep the material or prep this equipment for you. So the more time that you give us, the better. And it's not because we're putting everything in a particular sequence and we're pushing orders in one particular sequence. It's because we really do require time to make sure that all of the equipment is working properly. And then we're at the mercy of a courier system to be able to get things to you on time. Canister proofing. This is something that I believe I've discussed in the past, but for those of you that have not seen that in any of our documentation. We proof every individual canister every single time after we clean them. And that is the only way that we have to make sure that those canisters are clean. And we track that particular data cradle to grave for the canister. The batch proofing is what you see on your report. So why is the individual proofing nice to have? Because you do not need to ask for that individual proofing in advance. Say you get your results and you're looking at it thinking, you know what? I've never seen acetone at this site. Why am I seeing it now? One of the things that you can do is, and there is a cost, it's $100 for the proof, is ask for the individual proofing for that canister, just to make sure that there's no historical information on that canister that shows acetone in there. And so they will provide a certificate of individual proofing and we can upload that data. We only upload the batch data to the reports, but we have the individual data available if you need it. So the nice thing about that is you don't have to ask for it in advance. So never will you, when you're looking at your data to write a report, feel like, oh, I should have asked for that in advance. Now what do I do? We can upload that and we can provide those results to you. Leak checks at every stage. I can't state this enough. And the reason that I do is because we often get clients will say, well, did the canister leak on its way? Because now it looks like there's more sample in it than there was before, or less sample in it than there was before. Keep in mind, as I had mentioned before, that you're measuring with an analog vacuum gauge. And when we get it into the lab, we're measuring with a digital gauge that measures to 0.01 inches of mercury. So there is a big variation there. So there will be as far as the equipment, there will be a variation sometimes as far as final. It will be close. But again, we're talking about a whole air sample. So that slight difference will not impact your result as long as the canister is filled appropriately. Cleaning cycles. So when a canister goes through its proofing, as I had said, we individually proof them. It may take 3, 4, 5 different cleanings, and that's heating the canister and then purging with nitrogen, heating the canister again and purging with nitrogen. And then it goes on to the instrument to be analyzed to make sure it's clean and passes its required QC. So the cleaning cycles can take a while. The equipment for the flow controllers goes through exactly that same process, heating and purging. Now we don't purge them with nitrogen, we heat them and we clean them. We do purge the individual lines, but we heat them and we clean the individual components to the flow controllers. The canisters are actually connected in the oven. If you were to look in our ovens, and they're actually connected up just with with the quick connects in order to allow for the heating and purging process. So this ensures that the canisters are clean, but it is done multiple times. So if a batch fails or if an individual canister fails, back it goes in the oven until it's cleaned again. And so we do that multiple times. It takes longer obviously for dirty canisters to get clean. So if the canisters had high concentrations, then it does for the ones that had very low concentrations of material in them. So but we have the ovens going constantly. So our process, while we do not have staff in the lab for the full 24 hours, we do have the lab staffed about 20 to 22. The equipment and cleaning equipment runs 24/7 and also runs on the weekends. As far as the cleaning cycles for the thermal desorption tubes, and I'll mention that here, we will talk about a little bit later, but the cleaning cycles for the thermal desorption tubes are a little bit different. The thermal desorption tubes are stripped. So when they go onto the instrument, they're thermally stripped. So there's the thermal desorption GCMS literally heat strips the sorbent material inside and takes that and concentrates that onto a trap, and then that's analyzed. What we do then, so at this particular point, we're getting greater than 90% recovery off of that particular tube. What we do then is we actually have a tube cleaning instrument, and so it goes back on that instrument again for cleaning. And we do batch proofing with the tubes. We don't individually proof every tube because of the high recovery on the instrument. And then when it goes through the cleaning cycle again, when we do this batch proofing, they come back virtually completely clean. If the tubes don't pass QC, they're pulled out of circulation. The same goes for the canisters. The nice part about the selenite canisters is if we get to the point where they have to be pulled out of circulation because the QC doesn't pass, if it's a concern that perhaps the selenite coating on the inside is not as robust as what it was, we can actually send them back to the manufacturer and they'll recoat them for us. So from a carbon footprint standpoint, we are actually minimizing what ends up in either metal recyclers or in a landfill, because we can reuse these canisters and we can recoat them. Shipping times. So within Ontario, I'd already explained the network works quite well. We can get things ready, within 3 to 5 business days. If you're looking at longer than that, and I do have that in one of the subsequent screens, I'll give you an idea of what shipping times are. And we have explored this with other couriers, including FedEx and DHL. And we found that as far as reliability and accuracy, we're still getting the best deal and best service with Purolator. So we had left Purolator for a while for those of us, or for those of you that have worked with ALS before, but we are definitely back with Purolator in Canada. In the US, we are very successful with FedEx shipments, but not in Canada. We're using Purolator pretty much exclusively. Receiving, when we receive the canisters, they're checked for their vacuum right away, and that is marked down, and that's when the canisters are not filled and are going to require dilution. That's when you either receive an email or a call from us if there's a concern, in order to confirm whether you want us to go ahead and do the analysis. And this is based on the understanding that if you're trying to meet health-based indoor air criteria or ambient air quality criteria that are really low, that a 2 times dilution may even invalidate your results or make the results not usable. And in that particular case, we would just charge you for the use of the canister if you don't want the results, and we simply then put the canister through the cleaning process. I'd already mentioned about the diluent gases and the pressurizing leak check. We have a screening process, and this is something that we utilize. It's a shorter process and allows us, if we suspect that the canisters have high concentrations of material in them, or if the client has been very forthcoming because they knew that there is a particular compound of concern at high concentrations, we have a screening process set up to be able to tell if we're going to have to dilute. And we will then draw air out of one canister and dilute into another. And we can do this with all sizes of canisters, whether we're using the 1.4 liter canister or the 6 liter. We can even use the 1 liter bottle vac or the amber glass canister that we have and run dilutions. So again, similar to what you would see with water, where you can do a dilution of a highly contaminated water into a clean lab sample, we can do the same thing with canisters. Regular versus low-level cleaning. This has to do with one of the questions that we always ask clients as to what criteria they're looking to meet. The low-level cleaning, requires a longer cleaning process, requires heating and purging for a longer period of time, because we're trying to hit usually orders of magnitude lower in order to be able to meet things like your health-based indoor air or your ambient air quality. Now, your question will be, well, why don't you clean everything to low level, and that way it's never a concern? If we were to do that, the length of time to be able to clean all the canisters and send them out would be increased. The cost for cleaning the canisters would be increased. So we split the canisters up. We have low-level ultra-proof canisters, and there is a cost of $145 to rent those, but they are proofed to extremely low levels, and we can ensure that we can hit those low-level criteria. Whereas the regular canisters that you're using for things like soil vapor, for things like ambient air, where you're not looking to meet health-based indoor air criteria, for diagnostic, where you're looking to look at landfill gases, those low-level canisters aren't required. So when we split them up as a service to a client, we're better able to service you as far as the length of time it takes to get the equipment ready. And also, low-level canisters remain low-level canisters and remain at that quality control level, and the regular canisters can continue in regular production. What if you change your mind when you get your canisters? And that's not necessarily because the job has changed, or the job itself, it has changed. It may be that the job has been canceled and now you want to utilize the canisters for a different process. Let us know which canisters you've got, and we definitely need the serial number. So if you can scan in the media order form that you've got, what we will do is we will go to the individual proofing for those canisters to confirm whether we can or can't do it. Classic example is we'll get clients who want to do TO15, and when they get the canisters, they need to do the BTEX F1, F2, and they need the subfractionation, so the aliphatic and aromatics. That's not impossible. However, if you've ordered the canisters for TO15, then we know for certain they've been proofed for that. In most cases, we've proofed for more. So, but the only way for us to determine that for certain is for you to get back to us and let us know what you want to change. If we can't change, then we would have to switch out the canisters. You send us back what you've got, and there is a canister return fee, and then we then send you what you do need. So just keeping in mind that it's not impossible to change. I would say the vast majority of clients, when they call us to change the testing that they need, we can provide that. But there are times when, if we haven't looked at the total petroleum hydrocarbon fractions 1 and 2, so your gas, diesel, then, and the canister wasn't requested for that there may be a switch that has to happen. So always keep in mind that it's not impossible to switch, but that's why we ask in advance what you're looking for as far as analysis, because we make sure that that individual proof passes that with no question. So here's the logistics I was talking about. So ground shipping. So if you're going to Winnipeg, or pretty much, unless it's remote, most places in Manitoba, it's 3 days. Regina and Saskatoon, it's 4 days. And that means not that Monday would be day 1. So if I'm shipping out on Monday, day 1 is actually Tuesday. And Calgary's 4 days, Edmonton's 4 days, and Vancouver is 5 days. So why is this important? Because this, if you're ordering, for example, and you're out a job, or you have a project out in Vancouver, and you said, well, I'm calling, letting you know a week ahead of time, note that it's 5 days just to get it to you. So that now means that I have to ship tomorrow. And unless that equipment is ready and I can pressurize the canisters and do all the leak checks and get the flow controllers ready that night and have them in stock and everything ready to go, which I'm happy to say that when I looked back at the different stats, more than 90% of the time, that isn't a problem. But there is always a risk that we will not be able to accommodate. So please always check ahead of time to make sure that we have the stock. We don't like to disappoint our clients. We don't like to bump orders out. It's not something that we do often, but the more notice that we get, the better it is. If you have a project and you know a month ahead that you're going to need it, put the order in then. If you change your mind, let us know the week before. So before we have to ship it out, you'll know that we're going to ship it out. Say if you're, for example, in Edmonton, and you need it for Friday, the 24th of September, you know that we're going to be shipping it out on the 20th. If on the 15th you find out the job's been canceled, let us know and we'll pull it out. But at least we know, and we have lots of notice, and we can make sure that we get that out to you. So the more notice we have, the better it is to be able to get your equipment to you. When we talk about logistics, the other thing I want to mention is that when you get the equipment in, if there is something in there that just doesn't look familiar, or there's a part there that just seems unusual, please call us. Give us a call. I'm happy to go on either FaceTime through either my iPhone. I have my phone with me 24/7. Our staff is more than willing to help. If something doesn't look the way it should, or if you're concerned, call us and we'll go through the equipment with you. If the setup isn't what you expected, you get tubing and nuts and ferrules and a flow controller and you have a duplicate sampler, please call us and we'll be happy to run through how that is to be set up with you. I can't set up a sampling train to whatever you're connecting to, but we can do the other part of what has to happen connected to the canister. So if you need that help, that's what we're here for. And we're happy to run through the different parts of the equipment. I recently talked to a client who was looking at doing 6-liter canisters, had never really done ambient air, had always done soil vapor. And so the setup is a little bit different. The canisters look different. And so, we went through it. We did a video online chat to go through the equipment. I have 6-liter canisters here in my office. I have a 1.4 liter. I have a bottle vac so that we can actually run through the process of how the setup would be to connect onto the canisters. The other reason that I have this particular slide up is for the hold times. So when we look at the canisters coming in, again, as I had mentioned, when it comes to fixed gases and sulfurs, we do ask for for them to be in separate canisters. The one nice thing that you can do with those is if you're taking into a 1.4 liter can, you could ask for a duplicate sampler, and that way you're taking a true duplicate sample. That it means that you're still getting the same sample going into both canisters. Keep in mind that when you do duplicate sample, if you're asking, say you ask us for a 8-hour, or let's say it's a 12-hour or flow controller, time weighted average flow controller. So that's the one with the diaphragm on it. Note that it will take 12 hours to fill one can and 12 hours to fill the other, because that's the flow rate that we set it for. So it's there to collect that 1 6-liter can in 12 hours. So if you've got 2 connected, it'll take 24. Most of our clients, if they're doing samples in a duplicate, they will cut their duplicate sampler time in half. So if they're taking 24-hour samples and say they're taking 8 of them and they're taking 1 duplicate, they will ask for 7 12 or 24-hour flow controllers and 1 12-hour flow controller to connect the last 2 canisters that they're doing duplicate on. And that's not a problem. And that way they're done the whole job in 24 hours. So it doesn't mean that after 12 hours that sample stops taking air into the canister, just to keep that in mind. And this may seem obvious to most. It just means that it's set to collect and fill 1 can for 12 hours and the other can, but when they're connected with a duplicate sampler, they fill simultaneous, and it will take 24 to fill them both. So you're still getting a 24-hour sample. So hopefully that makes sense. For the passive thermal desorption tubes, and we will talk about those at the end, the deployment time varies depending on the use that you have for it. You're not going to be collecting, generally you're not collecting for just a 12-hour time, and there's no flow controller attached if you're using passive VOCs. These are just deployed, and through passive diffusion sample is collected, but we will go over that when we get to the thermal desorption tubes. If you're doing siloxanes, we ask that you take the kit that we send you, and the kit will have a TD tube, it will have a syringe, and it will have a Tedlar bag. Samples collected into the Tedlar bag, 60 mils is drawn up, and that's deposited onto the siloxanes tube. And that stabilizes the sample. And as you can see, if you look in the center of this chart, it gives you a 30-day hold time. So I'm not going to read this particular slide, but I wanted to give you an idea of some of the applications that the canisters are used for, and the different sizes of canisters and what they look like when you get them. So the 6-liter canister has a valve on it and then a quick connect at the top, whereas our 1.4 liter canister, as you can see, it's just a quick connect. And why do we just have the quick connect on this particular canister? The reason for the, on the 1.4, the reason for that is to reduce the sampling area. So it allows for less chance of contamination. So the larger space that you have here, the more chance that you could have some contamination. And when the 1.4 liter canisters are run in duplicate, you would connect a duplicate sampler to both. Once the duplicate sampler is connected, there's still nothing happening. Nothing actually happens as far as drawing sample in until you connect the flow controller to the top. So your flow controller is what you would attach your sampling train to, much as you can see here in the picture on the second from the right. The sampling train is attached, and then once that's all attached, you attach it to the top of the canister, you start your time, and you fill the canister up this way. The reason that the TOV valves or the valves are included on the 6-liter cans is because generally when you're doing a duplicate sampler, you co-locate them. And so you would put them 2 side by side. And in order to start them simultaneously, you would make sure that that valve is closed on both cans, install the flow controllers on top, so the time weighted average, and then with 2 hands open the TOV valves at the same time. What determines which canister you're going to pick? And we do get this question quite frequently. Well, won't I get lower concentrations or lower reporting limits if I use a 6-liter canister? Back again to the whole air samples. No, it's a whole air sample. So we're drawing the same aliquot out of a 6-liter as we would out of a 1.4. The only reason that you use a 6-liter canister versus a 1.4 is the length of time that you are sampling. If you are dealing with things like ambient air and indoor air, quite often those are low concentrations. And so sampling over a longer period of time complies with things like health and safety regulations, Ontario, or it complies with labor laws. Or if you're looking at an ambient sample, or sorry, a residential sample, it complies with the time that there's actually somebody occupying a property. If it's an office or a workspace, 8 hours is probably a shift, so a work shift. Whereas with the 1.4-liter canisters, when you're collecting soil vapor, you don't need to collect the sample quite as long. And so that's why it's a shorter term sample. Bottle vacs are very similar, can be used interchangeably with the, as far as the 1.4s or the 1-liter bottle vacs. The one thing that is nice about our bottle vacs is they are ultimately disposable. So if it's a highly contaminated sample, then we can dispose of the bottle itself to a glass recycler, and it is significantly less costly than if we were to get a highly contaminated canister, which is one of the stainless steel with the selenite coating, and not be able to clean it. So if you're looking at things like a tank head sample, which is in the previous slide that you see here, that's that second from the right again, that's a tank head sample. So it's taking the solvent or whatever is in that tank, it's taking a sample of the head space above that. And so that quite often can be high in either fuel or sulfur compounds. And so quite often a 1-liter bottle vac is used for that. This is just an explanation of why the industry is moving towards selenite. So Summa canisters is a thing of the past. It's still used in the industry, but the cutting edge or the most innovative design is definitely the selenite canister, and for various reasons, which I can let you, if you're interested in a copy of the presentation, certainly we can provide that for you, and you can ask either Alejandra or myself for a copy of it so you can go through this. These are the duplicate samplers I was talking about. So this left inset, again, we build these for you. When you request a duplicate sampler, we, excuse me, we do take them apart. And as you can see, there's flow restrictors on these as well. We do take them apart and thermally clean them, and then we build them as you need them. Some of the additional equipment that we have available. So the soil valve adapter, the sort of background info on this one has to do with standard operating procedures that were set out by usually by government groups or by regulators that required a leak check be done prior to the flow controller. So the soil valve adapter looks like the inset here at the bottom right, and we can provide those for soil vapor samples. It allows you to have an actual valve to turn on and off, but again, you're increasing that dead air space. So you can see they are fairly long, and that dead air space allows for potential risk of contamination, sample contamination. Excuse me. So that is one of the reasons that we don't have them installed on the canisters, but if you need them, we can certainly provide them. The tubing that you see here with the nuts and ferrules, we no longer use the brass nuts and ferrules. They're Swage-Luck product. We use stainless steel, and that is for the reason that there was some VOC off-gassing, and so that was causing concerns, and so we completely have gone to stainless steel for that. We do have Tedlar bags available. We would prefer not to use them for standard sampling, specifically things like VOCs. They do have a tendency, because it is a porous material, to leak. The hold time is extremely short. So keep in mind that if samples are submitted in a Tedlar bag, we do transfer them into canister to stabilize. And while the Tedlar bags are relatively inexpensive, so they are $22 for a unpurged, and if you're doing VOCs, you'd want to purge, so they're $40. We do charge for the transfer into a regular canister, and it's about $75. So renting the canister at $95 includes the flow controller, and ends up you don't have to pay quite as much. So there is definitely a cost advantage to not using the Tedlar bag. You get a better sample and consequently better data. And independent vacuum gauges, we include one of these with every order, and they're usually with the paperwork. Canister do's and don'ts. The reason for these is mostly obvious. And again, I'm not going to read through them in great detail. I just really feel that it's important that we're aware that there are certain things that should be done and things that shouldn't be done. If you have a 1.4 liter canister, don't put the flow controller on it to check out to see if it's working unless you want to be sampling. As soon as you put that flow controller on, you're sampling. The canister rental time is 2 weeks. These are pretty straightforward. We don't need the canisters chilled. Don't put ice in the cooler with canister. We don't need them to get wet. We don't want them to get wet. They don't have to be stored in a walk-in fridge. They can be stored at ambient temperature. Thermal absorption tubes. So this is what the instrumentation looks like. And if you can see, we put Teflon caps here on them. The GCMS that we use looks very similar to most GCs. If you've been in a lab or if you've seen lab equipment, they look very similar. The difference is obviously this particular portion of the unit where we actually desorb the thermal desorption tube and collect this particular desorb what is on the tube and put that concentrated onto a trap to be able to do the analysis on it. But this is what the thermal desorption tube instrumentation looks like. So the timeline. The nice part about the tubes is if you do know what concentrations you're working with and the compounds that you're running are something, or that you need are something that we run on the TD tubes. As an aside, we can do about 66 compounds routine on canister. The list is about 40 for TD tubes. We can get the tubes ready quicker. They don't take as long. We don't have to run leak checks on them. They are sitting ready to go. And so the timeline to get these is a little bit shorter. For when it comes to shipping, as you can see, this is one of our smaller coolers, and it actually has a foam insert that the little canisters sit in that hold the TD tubes. So much easier to ship than the tubes or the canisters are, easier to take out into the field. If you're doing active sampling, you have to have a pump. We don't provide the pump, but you would need a pump for that. If you're doing passive sampling, this is it. You need the tube. You need a diffusive cap at the end, and you can just see the diffusive caps. They're in a bag here. They go on the bottom of the tube when you deploy it. So again, timeline isn't as long. We can do them a little quicker. Reporting limits are lower. The cleaning cycles are faster. The shipping times go a little quicker. They're lighter. And when we receive them, we do check them to make sure that everything is intact. They have a serial number on them, and that number is reflected on the outside of the holder that they sit in. And we are currently, one of the things that I have added to this, and this is something that we weren't doing in the past because the recollect feature on the instrumentation we have was not doing a great recollection. And what that means is initially when we used to do when we were doing thermal desorption tubes, we could only analyze them once. So once we desorbed them and analyzed them, that was it. And the recollection feature, the recovery on it wasn't very good. If you recall what I mentioned earlier, our recovery was about 90% on the thermal desorption tubes, but the recollection was 50. And so that definitely is not good if the client wants you to reanalyze the sample, and we can only look at a 50% recovery. We have been able to go through the system and work with the manufacturer and get this working so that our recollection is significantly better. Obviously, the first time through is the best collection, but we are getting a great recovery for BTEX. So, and those are the only compounds we're currently working on as far as recollect. So that is something that we are currently doing, which means we have a second shot at some of these tubes. So if the data is somehow something that there's a concern for, or say the analysis was done and only benzene was requested, there's a great chance that we can go back and look at some of the other compounds. Active TD tube sampling. So these particular tubes have 3 different types of adsorbent. So a strong, a medium, and a weaker adsorbent. And that means that when you're collecting the sample is drawn in through here. The heaviest compounds collect to the weaker, the medium, and then the lightest compounds collect to that strongest adsorbent. This is the safe sampling volume discussion that I was mentioning earlier. So most of the VOCs have large safe sampling volumes. Some of the chlorinateds do not. And so things like vinyl chloride and there's another chlorinated compound do not have high safe sampling volumes. So if there's any concern that those may be present, you will have to limit the volume that you collect onto them. And because this is pump and tube media, it's flow rate and sampling time that you would multiply together, and then that would tell you your longest sample, or that would tell you your longest sampling time. And sorry, that would tell you the volume collected. I apologize. And that would be compared against the safe sampling volume. So again, when you're looking at sampling with TD tube, a great option if you're looking for lower reporting limits, as long as you know what compounds are present. Often what we'll have clients do is they'll take a canister sample to see where they're at. And then based on that information, if they'd have to do subsequent sampling or set up a sampling program, they'll decide whether they want to go with thermal desorption tubes subsequently. The passive sampling, I did put this in here just so you could see what it looks like when you're doing the passive sampling. Most of the time the tubes are deployed into outside into a weather shelter. If they are being deployed in a home, they just have to be suspended so that this particular diffusion cap is on there. That diffusion cap is critical to be on the tube to make sure that we can calculate the uptake rates properly. So that is taken into account when you're looking at the results for your compound concentrations. What limits the passive sampling VOCs is the number of compounds that we have uptake rates for, and currently we have about 25 VOCs. So they are limited. They are a great way of taking an unintrusive sample, so you can use them in an office space, especially if you have a target list of compounds that are within those 25 that we do. It makes it very nice to be able to put these in an office space and not have to run a pump. And they are deployed for a period of time. So it's not for a short period of time, they're deployed for a few days. They are not an event-based sampling. So over the 3 days, I would not be able to tell if on day 1, 2, or 3 was when there was a spike, for example, in benzene. So what you're looking at when it comes to these is looking at a total collection on the tube, and based over the amount of sampling time, you'll still get a concentration, but they're not episodic in that I can't tell when in that particular time there was a release of a particular compound, only that it happened within that period of time. And that brings me to the end. Are there any questions?
Thank you, Darlene, for sharing your expertise on this topic. This presentation was very informative. Before we begin the Q&A, I would like to ask everyone to take our survey. You can find the link in the chat section. I will give you 2 minutes. Thank you. We will open up the forum for questions now. Please write out your question using the Q&A function in the toolbar at the bottom of this webinar. I will give everyone a few moments to type in your questions. In the meantime, I will review some brief notes. This webinar presentation has been recorded. All participants of this webinar will receive a follow-up email once the recording is available to view. We also post our webinars on our ALS Global website and our ALS YouTube channel in the webinar playlist. Also, please follow our company page on LinkedIn as we post announcements and registration links to future webinars and other resources and updates. Okay, we have a question from Brenda. I ran tubes for several years and found that the capacity decreased and we had more breakthrough on the backup tube as we reuse and condition the tubes. How do you monitor tube VOC capacity?
So I agree with you in that after tubes have been in use for a period of time, the active TD tubes, they do end up having breakthrough. And so we do check these tubes. So when we do the batch proofing, they are monitored to check for breakthrough, and any ones that don't pass quality control are pulled out of circulation pretty much right away. I have to be honest with you, our active TD tubes are significantly, when it look at volume out of the location that I mainly work with, which is Waterloo, we generally work with the passive TD tubes, and they tend to be more robust, and that's probably because they're not drawing air through them at a particular higher flow rate. But you are right in that the breakthrough does happen, and so we end up we try to condition them to a period of, or to a point where they're usable. And if they don't pass QC, our QC is pretty strict for the active TD tubes, then we do pull them out of circulation.
We have a question from Rui. If the final vacuum pressure received by the lab is 0 Hg, the starting vacuum is 30 Hg. Does that always indicate in an invalid sample?
That's a really good question. No. So most regulators and the general industry has always come to accept that the canister shouldn't get to atmospheric. We have no trouble analyzing a sample that has gotten up to 0. The concern that has been raised when you get to atmospheric is that at that particular point, because your flow controller is set to collect at a particular flow rate or for a particular period of time, once you get to atmospheric, that flow rate is irrelevant because you no longer have a passive draw. You no longer have a negative or a vacuum pulling air into the sample. When we check the canister, we still have to use the diluent gas there. So we can still provide the analysis. We have, however, had some regulators note that in their documentation, they do not approve of the data if the canister has gotten to 0. So it doesn't present a problem for us as far as analysis. And as far as the data is concerned, the data is relevant. It has more to do with the regulator or the body that's going to be approving or reviewing the data.
Do we have any more questions? Catherine is asking, we have used helium to the leak test our sampling setup for sublab vapor sampling when using Soma canisters to test for hydrocarbons. Would this affect any of the lab data for the canisters?
No. To answer your question sort of as a short answer. So when you're using helium as a leak test, it does not affect our analysis. One of the things that, because we don't analyze for helium itself, and so therefore, even though it is used, and you probably are referring to when I mentioned that it's used as a carrier gas on the instrumentation or used for our fixed gases as the diluent, The only time that I would say helium becomes a concern is if you're actually doing analysis for helium. And in most cases, if you're not analyzing for helium, it's because your leak check didn't pass. And so that is one of the things that then, of course, then you want to know what results there are. But we don't on a regular basis do helium analysis on any of the samples. So the fact that you've added helium does not impact our results.
Okay, another question from Rui. What is a reasonable pressure difference between field end pressure and the pressure when received by the lab?
So this is kind of a twofold answer. The best way to look at the variance, if you are dealing with temperatures where it's neither super hot or cold, which is sort of in the spring fall, then the variance is generally should be no more than about maybe 3 inches of mercury, maybe a little more. However, keeping in mind that as the weather gets colder now or is hotter through the summer, that variance could be as much, and I know I have seen as much as 5 or 6 inches of mercury. The biggest concern for a client is that they see that variance and worry if that's somehow going to affect their results. The only time that you will see an effect on your results is if the canister is underfilled and we would have to do a dilution. So again, we can still analyze the sample. If the canister is filled to, that's why we say to between -5 and -8, because if you fill to -5, even if there is some heat expansion of the air because the sample has gotten hot, it won't be more than 3 inches of mercury. So it might be -2 when we get it, but it's still under vacuum.
Christopher is asking, for the 2-week rental fee, would that start when the canister is received at the local ALS depot? He's in Regina.
So for us, the 2-week rental fee starts from when you pick it up. And I have to preface that with, we ship them out to hit the date that you need them by. We're not inflexible. If you pick up the samples, say you're supposed to pick them up on Friday, the 24th, and you don't pick them up until Monday, the 27th, make note of it and state, like pick them up on Monday, the 27th. If you're going to keep them 1 or 2 extra days, we're usually fairly flexible. At this particular point in time, we start calling for the canisters back if they've been in your possession for close to 3 weeks. And so we're not hard and fast on that particular 2-week. We're trying to be as tight to that as we can be so that we can be able to provide supplies to all of our clients. We just ordered 100 more canisters in the spring, and we've literally, we go through them very, very quickly. We have a huge stock when it comes to canisters, but we try to keep in that 2-week window. We're not inflexible if it's going to be a day or 2 either way.
Okay, it doesn't seem like we have any more questions. I would like to thank everyone for attending our webinar today. You can contact Darlene for any questions, and I hope everybody enjoys the rest of your week. Thank you, Darlene.
Thank you, everyone.